All right, we're gonna get started. Okay, so if you have an issue with Matlab, I think we went over this last time. I think Osceola kind of sent the link in the Discord. So I'll show you guys what to do though. I had to do it last night too. I delayed it till then. Okay, let me share my screen. Okay, so if you have a Matlab issue, sorry, I'm turning up my sound. Okay, if you have a Matlab issue, basically what you gotta do. Oh, there's a spoiler for later on. So you're gonna have to go to help, and then you go to licensing, and then activate software. So you're gonna go there, and then you're going to activate using the internet. Press next, and then basically you have to sign into your MathWorks account. So most likely you're using your email address for school. So type that in, and then type in your password, whatever that is. You're gonna press next. You're probably gonna have to then sign in to the actual website for fullerton.edu. So you'll probably get a pop-up, but sign in that way, and then it'll activate it for you. So if you have that kind of message from Matlab saying that your license expired today, then that's what you're going to do. So to go over it again, you're going to go to help on this main tab here. Help, and then licensing, then activate software. So Ryan, I don't know why your login didn't work. It should work. Maybe you had the wrong email address? I don't know. If you can't get it though before class starts, then I don't know, I guess stick around after class, or actually just go into office hours today, and then we'll kind of go over it there. Okay, so before we get started on the lecture today, we're going to go over the second project. So, but even before we do that, I know there was basically a request, a very valid request to get the grades kind of looking correct on Canvas. So, yeah, before Canvas showed like the grades were, I don't know, like all of you had like 300% in the class or something, which obviously isn't really reality. So I fixed that where it's finally showing the grades correctly. So you can take a look at your grades. One thing though, if you go to like project 2 and we click on that, it says up here that the assignment doesn't count towards the final grade. Well, it does, of course it does, but basically I had to kind of show it this way right now, so it's not counted toward your grade right now, where it would be 0. So of course this project is going to count towards your final grade. And as for project 1 for grading, I know I told you guys that I wanted to get it done over the break, and I'm almost there. I've fully graded a few of the projects, so you might be able to see your grade even though I told Canvas to hide the grade, but who knows with Canvas. So hopefully I'll get them done by, I don't know, by this Wednesday. It's, of course it's going to be a busy couple of days for me, and I'm sure you guys too, but I'm trying to get those done as soon as I can because I know you guys deserve to see your grade. But so far the project looks good. Project 1, you guys did pretty good. Basically, if you did the project, if you were able to complete it, you got a good grade. Some of you struggled with the project, so if you struggled with the first project, hopefully the lecture last time when we went over the project, project 1 that is, the coding for that, hopefully that helped you out so you're ready for project 2 and you can kind of come back. So let's actually quickly go to the syllabus too, just to refresh you. This is the grade breakdown. So homework is 15%, quizzes are 30%. Project 1 was 20, and then Project 2 is going to be weighted more than Project 1. So Project 2 is 35%. So make sure that you're prepared for this project. And of course, Project 2 is just Project 1 mostly, but with looping. And we're going to go over the second project today. And we're also going to have a quiz this Wednesday. It'll be for sure this time an easy quiz. It'll be based off of the lecture today. Okay, any questions before we get started on the second project kind of overview? Okay. Oh yeah, so for the homework, that's I think it's due this Friday, I think I said. I'll check that right now. I'm blind. Here we are. So this is due December 4th. Is that this Friday? I don't know the date. Yeah, that's this Friday. Okay, so it's due this Friday, and then I'll upload the solutions for that this Friday as well, because this project is going to help you with the with our final project. Yeah, so I know there's been some struggles with the homework, so keep working on it, basically. But I also help you guys in the Discord. I know I wasn't as active on the Discord server over the break, but I'll pop in there and help you guys out, or go into office hours today too. So yeah, the homework should help you a lot with the project. So make sure that you understand the homework. Okay. Okay, so let's go over the second project now. So I uploaded the specifications over the break on like Tuesday or something. So if you're on the homepage for our class, go to project 2. And then here, I'm putting all the data here right now, and I'll basically just upload the most recent data right here. So I haven't updated these in, I don't think since I first uploaded it, but doesn't matter too much. So basically you can download the specs right here. Okay. I'm just going to open it on my computer though. All right, here we are. Okay, so before we really start talking about this, the important dates here. So I'm going to have it due on December 20th. So let's check what day of the week that is. I think that's a Sunday. Yeah, that's a Sunday. So I'm going to have it due December 20th by 11:59 p.m. And so basically, if you have finals to study for, which I'm sure you do, you can study for the finals, and then you can finish up your project after your finals, so you don't need to kind of worry about this too much also. You're still going to probably have to worry about it a bit, but hopefully not too much. So this is going to be due after all of your finals. So you can work on that after you do your finals. Okay, and then the date for data upon submission. So the data that I upload on Canvas. Let's go back to project 2 here. So this data that I upload here, when you submit your project, the date that you should be using is going to be December 16th. So I believe that's the last Wednesday that we have for class. So yeah, that would basically be when we would have our final for this class. Of course, we don't have a final for this class, but you're going to use December 16th for the data that you use for your script. And I'm going to upload that as soon as it's available. Okay. So project overview. So this project is again basically going to be the same as project 1, but with looping. Now there's going to be some differences, which I'll talk about, but for the most part, it's going to be like project 1, but with looping, because that's the next big thing for this class. So for project 1, the two main things we focused on was array addressing and plotting. And the next big thing for the class is looping. So we're adding that on for this project. Okay, so for this project, what we have for the data is population for California counties. So before, for project 1, I basically gave you the population in a spreadsheet where I basically appended the population for each county. But this time I'm just going to give you the population spreadsheet by itself. So let's actually open that up. And I'm going to be careful not to show you guys some of these figures. Okay, so this is what the spreadsheet is going to look like. Of course, it looks a little weird here, but basically it's just, the county and the population for each county. So I'm going to give that to all of you. And then the other spreadsheet we have is statewide cases. I'm going to stop sharing so I don't show you a plot. Okay, let me pull this up. Okay, so the other spreadsheet that we have is statewide cases. So this is what you had in project 1, where you have the county, you have the total amount of confirmed COVID cases, the total amount of confirmed deaths, and then you have your new COVID cases per day, and then your new deaths per day, and then the date. So you guys had this spreadsheet in project 1. We're going to have it again for project 2. And then we have one more spreadsheet here. So this time we're going to have hospitalization data. So this is similar for how the statewide cases spreadsheet was. But for this, it's hospitalization data. So we have the county, and then you have the date for the data that was uploaded. Maybe I should open this in Matlab. It'll look a bit better. Let's do that. Okay, so yeah, this is the spreadsheet. So you have the county, you have the date for the kind of testing date. Then you have the confirmed hospitalizations that's due to COVID. And then you have the suspected hospitalizations due to COVID. And they're pretty long column names, I know. And then you have hospitalized, confirmed, or just hospitalized COVID patients. And you have all hospital beds. Let's start moving some of these over. Then you have confirmed patients that are in the ICU because of COVID. And then you have suspected COVID patients in the ICU. And the last one is the amount of ICU beds that are available. Okay, so basically what we're doing for this project is we're only going to have county data. We're not going to have global data or states data. And one of the reasons why we're doing that is, one, I think it's just more relevant to us looking at, county data for California, because that's where we all live. And also the global data, who they kind of changed the way that it's shown now. And I'm sure I could kind of dig into it more, but they don't show the day-by-day testing data, so it's kind of annoying. But so yeah, that's why we're just going to use county data this time. Okay, any questions so far?
As for graphs, will they look the same as the one in the previous project, or will they be different?
Some of them are going to look the same. Well, see, I don't want to say that they look the same because, we're going to have the date is going to be different. So the graph is going to look a little different, but the rest of it will look the same. Now, does that make sense?
Okay.
Like the formatting will look the same, but the actual graph itself, that'll be different.
Oh, okay. Makes sense. Thank you.
Okay, yeah. And obviously, we know we're not going to have the global or the estates plot. This time, we're going to have hospitalization stuff too. So I'm not going to show you guys the graphs this time around because basically now, and especially after you actually see your grade and all my feedback for project 1, you should know what's expected for the formatting for the plots, and I also have a section in the handout here too that goes over the expected formatting. But basically, at this point in the semester, you guys should know how your plot should or shouldn't look for the formatting. So, some of this is going to be up to you, kind of a judgment call for the best way to display it. But now you have a basis from project 1 and my feedback for project 1. Okay, so the report structure, it's going to be a little bit different on this project. So we're going to have an introduction, just like we did for project 1. So tell the audience, and I guess a little aside here, for your intro, you should pretend that you're talking to some audience, in the scientific community at large. I know that sounds like kind of vague and or cheesy, but pretend you're writing to the scientific community at large, or like a friend that's in a different class or something. So pretend you're doing it that way, and you're reporting whatever data that you're showing. So it should be a formal written document, but pretend that you're kind of presenting this data to, again, the scientific community at large. Okay, so tell them what you're going to show, and briefly talk about how you're going to post-process the data. So you should mention the use of Matlab, array addressing, and for loops, stuff like that. And that's what I said too. And then you're going to discuss the importance and benefits of using for loops as compared to the methods that we used in project 1. So in project 1, we had to kind of go line by line ourselves, but this time we're going to use loops, so we don't have to do all of that work. Okay, so after your intro, you're going to have your results section / write-ups. So for this, you're just going to have the write-ups basically. So you're going to have it for rolling stats, which you'll see on page 3. So here's page 3. We're going to have that breakdown. Okay, so you're going to have write-ups for all the rolling stats, and you should first talk about importing the data. So, we'll get that out of the way. That's only a few lines of code, though. And then you're going to have a write-up for all other lines of code needed up to the plotting code. So I know this is going to be a lot, but basically you can just copy and paste quite a lot of it, and then you can kind of modify, little sections as needed. We'll talk about that in a second. And then for the plotting, for that, we're only going to have 2 write-ups here. So you're going to have one write-up for the total deaths per million people for the top 7 populous counties. So that's different than last time. For project 1 is for the top 5. This time it's for the top 7. That might seem like an arbitrary number, which it kind of is, but it's 7 counties because we can have 7 unique colors in Matlab when we plot it. You can break down the colors even more in Matlab, but for that, it gets a little more complicated, so I'm just going to do 7 counties. And then you have one more write-up for the plotting, which is going to be the current amount of confirmed hospitalizations per million people for the top 7 most populous counties. Okay, so for the figures, you're only going to have 2 write-ups. Okay, so again, the write-ups that you have, it's a lot because of these rolling stats here. But you can copy and paste it for a lot of this stuff because, for project 1, I told you if it's similar to some other line of code, you can just reference that, but there was some confusion on, what you actually had to do a write-up for. So basically, to avoid that confusion this time, I'm just going to say you need to have a write-up for all of this stuff here, all of these rolling stats, which you'll see on page 3 right here. So that's a lot, but what you can do is just copy and paste a lot of this stuff. And it's actually not going to be like this. Looks like a ton of stuff here when you first look at it, but we're using looping, remember? So looping for a lot of this stuff is only one line of code. So it's not going to be quite as much as it looks like right here. Okay, let's move on. So then after we have the write-ups, then we're going to have the appendix. And this is where we're going to put all the figures. So in project 1, you had your figures in the results section. But basically, I just want to look at all the figures in one spot this time. So we're going to have all of the figures for the report in the appendix. And I list out each figure that you should have. So we have a lot of figures here. So we're first going to have a section for cumulative stats. So we have total cases and then total deaths. So you're going to have 4 figures right here. And then you're going to go into the rolling stats. And that'll be new cases per day per million on a 7-day average for the top 7 most populous counties. And then we have the same thing, but for deaths. And then we're going to go into all of this hospitalization data. So we have the current confirmed hospitalizations, then current confirmed per million, then current confirmed ICU patients, then current confirmed ICU patients per million, current confirmed ICU patients on a rolling average. Then we have the ICU beds. We have 3 more right there. Ryan, you have a question?
Yes. Will we be putting these rolling stats in their own separate figures or in a little miniature table?
You're going to put them as their own figure. So you're basically just going to have, this is going to be over the span of a few pages, just each figure kind of shown. Okay, so those are all the figures, and then after that, just like project 1, you're going to copy and paste your entire code at the end of the report. Okay, now we have the grading breakdown. So this will kind of help give you an idea of what you should, make sure that you have in your report. So the first thing, we're going to have the validity of your code. So what I want to see is, did your code run for me right away without any modification? So basically, I should be able to get your code, put it on my computer, and press run, and it should run, and there should be no errors, or I shouldn't have to change anything. And then I'll check if the correct graphs were generated as well. And then we're going to have the next section will be on the code structure. So I'm going to see if there's any hard coding that was implemented. So make sure you don't do that. Now for project 1, if you did hard coding, that was okay. I didn't mark you down for that. But now that we're at this point in the semester, you should know better kind of coding techniques. So you shouldn't use any hard coding. So basically, you'll use the methods that we went over in the last lecture when we went over the coding for project 1. So, an example would be instead of specifying through hard coding 7 days for the moving average, you would reference some variable that showed the moving average. Okay, and then for the for loops, were they used when specified? So I have, this section here for required for loops. And then, of course, were they constructed correctly? And then the next section we have here for your grading breakdown is the report content. So I want to make sure all of the report components were present. So that means your intro, your write-ups, and then your appendix with all of the figures. So you need to have all of the figures in your report. Some of you didn't have all of the figures in your report for the first project. So make sure that you include every single figure that's listed right here. Okay, and then were the write-ups well explained? Okay, I skipped one. Did the write-ups cover every aspect of the code? So you want to make sure that whatever code you have, that you actually explain every aspect, of course. And then were they well explained and easy to follow? And then were the generated plots formatted correctly as per the requirements? And again, I have the requirements later on in this document. Okay, so the required for loop. So of course, this is the main focus for the project using for loops. So I want to make sure that you actually have for loops in your project, of course. So you're going to need to have all of these for loops that I have listed out here. So it's quite a lot. But you can have a for loop, and I kind of show the format here. You can have one for loop for these two things, and you can actually have in that same for loop all of these as well. So for the homework, you can kind of get an idea too, where a lot of the times we can have one for loop and calculate a lot of things within that for loop. So basically, I just want to make sure that you have in a for loop all of these things here. So you're going to need to use a for loop to find the indices for each county. So basically, you're going to find your index for this will be each county, right? So you're going to say for I equals 1 to the amount of counties that we have, and then you're going to find the index or the indices for each county. And then you're going to use those indices to get all of the data for each county. So when I say all of the data, that means you're going to reference one of the spreadsheets to get the the total amount of cases, of deaths, etc. So you're going to be getting all of that. And then we have this section for totals. This will be finding the total amount of cases for each county. So again, your index here is each county. And then the total amount of cases per million, total amount of deaths, and total amount of deaths per million. And then the next section is for the rolling stats. So that'll be the new cases per day for each county. I mean, you can read it. And then we have hospitalization stuff as well. Okay, so for all of this stuff, you're going to be using a for loop. And this isn't to kill you. You need a for loop to do all of this stuff. Otherwise, you'd be going, again, line by line for each county, and that would be terrible. Okay, so any questions on this?
About how many lines of code do you think this will be total?
I looked at my code last night, so I looked at it up until the plotting. So I'm not counting the plotting code. I think it was 200, 250, but that's with spaces and a lot of comments. So the actual coding itself is probably around like 100 to 150 lines of code. So it's actually probably less really than your first project.
Okay.
I'm gonna check how long my code was for the first project. So for the first project, before the plotting, I think I added stuff for this. Okay, for the first project, it was about 130, but I added some stuff, but it'll be around the same. Actually, it's a little more for this project, but it's not too bad. Okay. Actually, I'm gonna check really quick how long it was. Okay, so yeah, before the plotting, I'm at 250 lines of code. But again, I have a lot of comments in here, and of course spaces as well. So really, it's probably around, I don't know, 150 lines of code. All right. So now that we have all of that out of the way, now we have the recommended attack plan. So my screen just went black. It's back now though. That was weird. Okay, so I'm gonna give you guys this kind of recommended attack plan. This is only for one portion of the project, but so it's for cases and deaths. But this attack plan here is going to be very, very similar to what you're going to use for the hospitalization data. You just have different data, of course. All right, so yeah, I want to give you guys, kind of some hints, I guess, for what to do. So this is what we're going to do. First, we have to import the data, of course. So you're going to import all of the data. Then you're going to make the necessary conversions from a cell to a string. So if you have a county name, that column, by default, it's a cell. And for plotting reasons and for, I think also for looping, it's best if we convert it to a string. So you're going to convert it to a string. We've done that in a lot of the examples in class. So we're going to do that. Then our next section here, we're going to specify some plot parameters. So we went over this last class as well. Did I forget where I stored our example from last class. Let's see if it was here. Yes. Okay, so what we did in our lecture last time is we had a little section here that was called plot parameters. So this is the kind of code that we used so we can avoid hard coding. So we specified a custom date for our plots to start at, and then we specified the amount of counties or countries in this case to use, and then the rolling average to use. And later on in your code, you're going to reference these variables so you don't actually hard code the specific number. Okay, so that's when you're going to have that section there for plot parameters. Okay, and then our next section is the actual data reduction. So the first thing we're going to do, so this is for the spreadsheet for statewide cases, we're going to remove the non-counties that we have. So we have some entries in that spreadsheet that's called unassigned and out of country. So you guys did this for the first project too. You're going to remove those because, they're not, at least for this project, we don't want to look at them. Okay, and then in a for loop, we're going to get the indices for each county. Then we're going to use those indices to get all of the data for each county. Then we're going to use a logical operator to determine which counties do not have testing data for the entire testing range. So if you were going to look, here it is. So if you were going to look in Matlab and you open up this spreadsheet. If you were going to look at this, you'll see that some of these counties, they actually don't start at the same date as others. Okay, I can't move that. There we go. So some of these counties, they don't start their testing date on March 18th. So I think there's like 5 of them or something. So what I'm going to have you do is find which counties don't start on those dates, and then you're going to remove them. So we're going to use a logical operator to determine which counties don't start on that day, and then we're going to remove them. So this is to simplify the project, because basically if you tried plotting this with the other counties, it wouldn't work because those the length of the vector that you have is different, and then we can't plot them because remember when we plot our vectors that we're plotting, they have to be the same length. So we're just going to remove the counties that don't have that entire testing range just to kind of simplify the project. Okay, so to actually remove them, we first use this logical operator, and then we're going to find the indices for those counties that don't have the testing data for the entire testing range, and then we're going to delete all of those corresponding cells. Okay, cumulative stats. So we're gonna use a for loop here. And you can already kind of see the structure that we're gonna have here. So first thing we're gonna do, we're gonna put our county names in a column. So we're kind of building not a table per se here, but an array. So we're gonna have the county names in a column. I think for me, I used a cell array. So you don't have to use a cell array, but I would personally recommend it, and that's something like that you do for the current homework. Okay, so we're gonna put the county names in a column. Then we're gonna put the population for each county in a column, and then we're going to again use our for loop to get the total deaths per county. Put that in a column. put the total deaths per 1 million people in a column. So you can kind of see we're just going line by line in our for loop here. Okay, and then what we're going to do, I think this, that should maybe be below here, below rolling stats. So for the rolling stats, though, we're going to get the new deaths per day, per county in a cell. So again, I recommend using a cell array just to kind of keep everything nice and organized. So we need the new deaths per day, but we're also doing that per county. So we're going to put that in a cell. So we're going to have a cell basically for each county. Then we have the new deaths per day per 1 million people per county in a cell. And again, you can kind of see what we're doing here. We're going to have a line for each of these things. Okay, and then you can do the same thing for the cases. And then you're going to make your plots. So to save some time, and I kind of showed you some of this, I don't know, formatting here. So I'd recommend to specify your position ahead of time, or the size of your figure. So you're going to use this command called position. And then here you specify the figure size that you have. And then this part at the end is just so I can run my code and the figure doesn't show up. Okay, and then we're going to avoid hard coding by referencing variables that we previously defined in our code. So if you see here, I have counties include, and that was basically just to specify the amount of counties that I was going to plot. Okay, and then you can use the export graphics function to export your figure. So instead of actually manually exporting your figure in Matlab, you can just have a line of code to do that automatically for you. So that's this line of code here. And then the visible command, I just talked about that. So since it's relevant, some of you didn't actually, kind of what I say is fully export your figure. So you want to make sure that you actually fully export the figure. So let's show you what I mean. And we had a lecture on this before as well. Okay, this isn't great code here, how I formatted it. Okay, what I'll do, I'll actually go back. Let me stop sharing really quick. I'm going to go to the current project. Okay, give me a second here. I don't want to spoil my code. Okay. Okay, so don't mind the ugly plot here. That's not the point. So to actually fully save our figure, what you have to do is go to File and Export Setup. So I think some of you in the first project you took screenshots of this. Shouldn't do that. It looks bad, number one. And a lot of your figures, they showed this as well, which shouldn't be there. So to fully save the figure, you need to go to File, Export Setup, and then you can specify the resolution, and then you press Export, and then you save it as a PNG or SVG. Okay, so you can do that, or with our coding, like I just talked about, we can just use this function called export graphics, and that'll make it easy for us to just save the figure automatically for us in our current folder. Okay, so that's just to save some time. Okay, last thing here. See, the document, is quite detailed because I want to, be very specific for what I want to see in the project and also what I recommend you do in this recommended attack plan. So the last thing we have is the plot format requirement. So your plot should follow these following rules. You shouldn't have any white space before your curves start or after the curves end. So some of you do that for project 1. So what I mean for that, I think I had a little spreadsheet or a file here. Okay, so some of you in project 1, you had white space before your curve and you had a white space after the curve. You shouldn't do that. You should have, your axis bound here. It should start here and then immediately your curve should start. And same thing at the end, the upper limit for your axis range. You should have the plot stop right there. Okay, so you shouldn't have any white space before the curves start and after the curves end. Okay, and then the next thing, the legends, they shouldn't block any of the plotted curves, so that was another issue for some of you. So either put your legend outside the plot, or if you put it inside, make sure that it's not blocking any of these curves. Okay, and then there shouldn't be any exponents present on any axes, so that was a requirement for project 1 besides the log plots. In this case, we don't have any log plots, so you shouldn't have any exponents on your axes. And then your figure title should be descriptive without being too long, so the most recent day of testing should also be included, and you shouldn't hard code the date. So we went over that as well. So you see in this code from last time, in the title we used a function called dateString to reference the current date of testing that we show in the plot. Okay, and then the last thing we have here is the tick labels. So they should be clearly shown, number 1, for some of the plots for the states for project 1. I couldn't even read the states because they were overlapping each other. So make sure for this, I don't think it should be an issue, but make sure I can read them and they should show the respective month for the rolling plots. And for the bar charts, they're going to show the respective county. Okay, Victor, I didn't see your comment, so our code should be formatted in this method. Was that for the plots or was that for the recommended attack plan section? Okay. It doesn't have to be formatted like this. It's just what I would recommend. I don't want to box you guys into how I code, and that's why I'm not going to give you starter code. But this is just what I would recommend. I think this is kind of a logical way to go through it. So you don't have to format it this way. I just recommend it, but you just have to make sure that you have these required for loops. But however you format it is up to you. Okay, so that's it for the document. It took kind of a while, but I want to make sure you guys know what we're doing and that it's in depth. So are there any other questions for project 2? Okay. Okay, so now we can finally get started on the lecture. We don't have too much time left though. I guess that makes your quiz this Wednesday a little more obvious what it'll be on. I guess you can kind of see some of my code here. It's just for plotting though. Okay. Okay, so we're just gonna do some odds and ends, that's what I'm calling it. So if you look at the syllabus, there's a few chapters that we haven't gone over. However, for those chapters, we've actually gone over quite a lot of this stuff. I'm just not in a lot of detail. So one of the chapters is for curve fitting. We've gone over that before for using the polyval and polyfit function, and there's a few other things like left-hand division. We've gone over that as well to solve systems of equations, but we're going to go over some of this stuff again right now in a little more detail. So I'm just going to call this odds and ends, but this is kind of a lot of the final chapters that we have on the syllabus. Okay, so what we're going to go over is random number generation. So again, we've gone over that a bit before, but we'll go over it in more depth now. We'll go over interpolation and then solving linear systems of equations. Okay, we're actually going to start on interpolation. I think that's more useful than the random number generation. Okay, so interpolation and extrapolation. We're only going to go over interpolation though. Okay, so for interpolation, basically what we have is we're going to estimate a value that's between data points. So, this is something that we have to do every once in a while. Especially if you haven't taken 306A, I just know specifically for one of those labs, you're going to have to use interpolation. I think it's for the Charpy Impact Lab. So if you haven't taken that lab yet, at least you should use interpolation for that specific lab. But in general, we have to use interpolation every once in a while. So Matlab has a function to do that for us. Okay, so again, interpolation, we want to estimate a value between data points. So as an example, let's say that we have this data here for temperature. So we have our temperature at 7 a.m., 9 a.m., 11 a.m., and 12 p.m. Maybe we want to look at the temperature, at 8 a.m. and 10 a.m., but we don't have that data. So what we can do is interpolate to get that temperature. Of course, it's not going to be exact because we don't have that data, but we can interpolate for it and it'll be at least somewhat accurate. So one method that we can use to interpolate is just plotting and then drawing some lines to connect the time that we're looking for, and then we can draw a vertical line up to our curve. Then we can draw a horizontal line from that curve intersection to get the temperature. So we'll go over how to do that right now, but really what we're going to see is that's not a very good method to use. It's time consuming and it's not as accurate. Okay, so we'll make a section called interpolation plotting. Okay, so what I'm going to do is just make a vector for our temperature and then another vector for our time. Okay, so let's actually see what I called it. Oh, cool, I didn't include the code. That's okay. Okay, so I'll have one vector here called temp. And we'll do 49, 57, 71, 75. Then we have another vector for the time, so that'll be 7 a.m., 9 a.m., 11 a.m., and then 12 p.m. So I'm just going to put numbers for that, and that'll be okay. Okay, so what we can do now is plot this. So I'm going to plot the time on the x-axis and then the temperature on the y-axis. And let's make this blue. We're going to have circles, and then I want to connect those data points with a dashed line. Okay. Oops, I see I put a number in the beginning. Didn't want to save. Okay. Why are you not showing me my plot? I'm going to close that in Matlab really quick. There we go. I don't know why that wasn't plotting before. Okay, so here's our plot. Where did I just put the slides? I closed it. Okay, there we go. Okay, so here's our plot. Okay, so took a little second there. So we have our hours on the bottom. So we have our time of day on the bottom. We have 7 a.m. up to 12 p.m. Then on the y-axis we have our temperature. So we have 45 degrees up to 75 degrees. Okay, but again, we only have the temperature for the time of day of 7 a.m., 9 a.m., 10 a.m., or sorry, 11 a.m., and then 12 p.m. So what we're going to do is interpolate for 8 a.m. and 10 a.m. So to do that, one method, we can just draw a vertical line from 8 a.m. and 10 a.m. and then we can find when that intersects our graph here. Then we can draw a horizontal line to the y-axis and then we can get the temperature. So that might be, a kind of an intuitive way to kind of go about it, but that's not going to be really a great method to use. But we'll go over this first, and then we'll talk about the better method to use with Matlab. Okay, so to do this, what we can do is use a function called, boy, I always forget it. Did I say it in the code? Yes, okay, xline. I always forget if it's like xline or hline. So we're going to use xline 8. And basically this will just draw a vertical line on our, from the x-axis where we have 8. Okay, so if I plot this now, then you see that I get this vertical line that shows up right there on 8 a.m. Okay, and then we can do the same thing for 10 a.m. So we're going to do x line and then 10. Right, and then we have that. So now what we can do is we can kind of just look from visual inspection, or we could actually draw a line as well from the y-axis, a horizontal line, and we can find when we have this intersection point. I think there's even an add-on package that you can get in Matlab to actually find the intersection point for this this curve intersection. But for sake of time, that takes too long, and I don't know it off the top of my head too, to be honest. So that's going to take too much time for us. But what you could do, of course, again, you can kind of look at this by visual inspection here and see that it's going to be at 10 a.m. We're going to be around, I don't know, 64 degrees. Yep, and then at 8 a.m. we're at around 53 degrees. But again, that's not a good method, so instead what we can do is use a function in Matlab to interpolate. Okay, so this function is going to be interp1. So interp1, the 1 stands for 1D data, so one-dimensional data. Okay, and then the syntax that we have here is interp1, and then xv and xq. So x, that's going to stand for our sample points that we have. So that'll be our x-axis. In this case, that'll be the time. V, that's going to be the corresponding value. So v of x, that'll be our temperature. The next q, that's going to be the coordinates that we have for our query. So that's, in this case, that's going to be 8 a.m. and then 10 a.m. Okay, so we can use this function here to just interpolate. So I don't even have to plot anymore. So, to use the same formatting that I was talking about for your project, what I'll do is add on some code here for visible and then off. So now once I run this, the plot, oh cool, it still showed up. Oh, I didn't put figure. I need to be in figure, that's why. Okay, so I'll do figure, and then I'll do visible, and then off. Okay, visible, off. Now when I run it, now it doesn't show up. There we go. Okay, so instead of plotting, what we can do is use the interpolation function. So interpolation function. All right, so the first thing that we have is our unknown hours. That's going to be our xq. So I'm going to make a variable here called unknown. That should say, well, we know which hour it is, but so I'll just say hours. I don't know why I said unknown hours. Okay, so we're going to do hours equals 8 and then comma 10. Okay, so we made a vector for those hours. We have 8 a.m. and then 10 a.m. And what we're solving for is the temperature for those hours. So we have to interpolate for them. So I'm going to make a new variable here called temp underscore 8 underscore 10. And then we're going to use our interpolation function. So we're going to use interp1. And then our x data, that's time. And then our y data, that's our temperature. And then what we're solving for is those is the temperature for the hours of 8 a.m. and 10 a.m. So we're going to put in unknown, or sorry, not unknown, but hours. Now if I run this, then we get 53 and 64. So 53, of course, that corresponds to 8 a.m. And then 64 degrees Fahrenheit, that corresponds to 10 a.m. Okay, so we just, that's all we had to do. We just needed 2 lines of code instead of plotting here and trying to just look at what the temperature would be by visual inspection. Okay, so any questions on that?
So visible off basically just doesn't show the plot.
Yeah.
So we could use it on the project.
Yeah, I would recommend that you actually do that. It would make it a lot easier for me to grade, to be honest.
So like, do we do that for every figure we plot?
Yeah. For each figure, you should have this line of code where it says figure, then you can specify the size, and then you can put visible off.
Okay.
Of course, if you want to see it when you're like looking at your code, you just change it to visible on, and then you can look at it.
All right. And
Yeah.
you said you put the size in front of the
Yeah,
visible?
so if you want to specify the size, you can just do position, and then you're gonna do a comma. Yeah, comma. And then in brackets, you'll do something like this. So what I have is 2 zeros. So these first 2 zeros, that corresponds to the actual position that your figure is going to show up on your screen. So, and that's in reference to the left-hand corner. So for you, if you run this right now, it should show up in the bottom left-hand corner of your screen. And these last 2 numbers here, this is the width and then the height. Well, yeah, I thought I typed this wrong. Oh, that's why. There we go. So now this shows, I have the width of 1000 and then a height of 500.
Okay.
Yeah, it just makes it very convenient for if you want to save the figures and you don't need to rearrange the size of it before or after you plot it. You could just do it automatically.
All right. Thank you.
Yeah, so I'm not going to mark you down if you don't specify the size and if you don't have this command for visible on or off, but it'll make it a lot easier for me to grade if you guys do that. Okay, so next thing for interpolation, we can also interpolate in a matrix. Am I not doing that yet? No, not yet. Okay, so we have a few restrictions for interpolating. So the first thing, the value that we're solving for has to be within our range for x data. So, in this case for our temperature, that we were solving for, we had to solve for it within this range for our time. So we were solving for 8 a.m. and 10 a.m. I can't solve outside of this range for interpolating. That would be extrapolating, but we're doing interpolating here. So our time has to be within this range right here. And then the other thing is that the values for x need to be in ascending order. So just make sure when you make your vectors, like for time here, that we're in ascending order. So we're going from 7 a.m. up to 12 p.m. Okay, so we can also use the interpolation function with the matrix. So we're going to basically extend our example here where we have our temperature at 3 different locations for the time of 7 a.m., 9 a.m., 11 a.m., and 12 p.m. Okay, so what we're going to do is solve for the temperature at 8 a.m. and 10 p.m. for all 3 of these locations. And we can do this with the interpolation function. So, I guess I'll just go over it. I was going to have you kind of think about it on your own and kind of work through it, but we're restricted on time. So, interpolation with the matrix. Okay, so the first thing, I'm just going to type this out again, pretend it's a whole new example. So we have our time, that's 7 a.m., 9 a.m., 11 a.m., 12 p.m. That's known. And then our hours that we're going to solve for, that's going to be 8 a.m. and 10 a.m. Okay, and then location 1, we're going to specify the temperature that we already know. So we know the temperature for location 1 for these 4 hours right here. So we're going to type that in. So for location 1, we know we have 49 degrees at 7 a.m., 57 degrees at 9 a.m., 71 at 11 a.m., and 75 at 12 p.m. Okay. And what I'm going to do is just transpose this so it's a column vector. Of course, I could have just used semicolons when I made this to make it a column vector as well. Okay, and then location 2, we have 52 degrees at 7 a.m., 60 degrees at 9 a.m.? Yeah. And then 73 degrees at 11 a.m., 79 degrees at 12 p.m. Okay, and then we're going to transpose it to make it a column vector. Then we're going to do the same kind of thing for location 3. Okay, there we go. Make that off. Okay, and now what I'm going to do is append our vectors here. So I'm going to do location total is going to be location 1, and then I'm going to append location 2 and location 3. So now what we're going to have is a matrix here for the total locations. Okay, so this is the temperature at each location right now. For the first row, that's 7 a.m. Second row is 9 a.m. Third row is 11 a.m. The fourth row is 12 p.m. Okay, and now what we're going to do is solve for the temperature for each location at 8 a.m. and 10 a.m. And again, we're going to use our interpolation function. So I'm going to do temp solution equals interp1, our interpolation function, our x data, that's our time, and then our y data, that's going to be our location total, so this matrix that we just made. And we're going to solve for the temperature at the hours that we have for 8 a.m. and 10 a.m. Okay, so once we do this, it's going to solve for the temperature, again at 8 a.m. and 10 a.m. for each of these locations. So now if I run this, then we get our solution here. Oh, I didn't suppress that. That's why. Okay, so we got that. So at 8 a.m. we have the temperature for each location on this first line or this first row. And then in the second row, we have the temperature at each location for 10 a.m. Okay, so it's a pretty simple function, but it's also very useful for, for this kind of stuff. Whenever you have to interpolate, you don't have to, do the math by hand. You can just do this. Okay, any questions on that? Okay. We're going to go on to linear algebraic equations. This is another very important thing. Okay, so we have, actually, out of curiosity, because I know there's like a wide range of students in this class for what year you're in. How many of you have taken linear algebra? Or if you're taking it now?
I have.
Okay.
I am.
Okay, maybe a lot of you have taken it. Did you take it like last semester, or when did you take it?
I took it last year at OCC.
Get nightmares from it. Linear algebra is great. Okay, well, so it looks like most of you have taken it, so whether you hate it or not, I mean, it can be pretty tedious, I know, but it is pretty useful, so it is very important, to do this stuff. I'm using it, again, for one of my classes I'm taking right now, and I'm using it with Matlab, and you'll see why, because it's going to save us quite a lot of time. Okay, so we have very basic, linear system of equations here, so all we have is two equations and we have two unknowns, x and y. So we could solve for this by hand, or some of our calculators, they have like an app built in to solve for linear systems of equations, so you could use that too. Or what we could do is use Matlab to solve for it. And for us, it's going to be really beneficial to use Matlab for when our system of equations get really, really big. They're going to be insane. Like if you have even a 5 by 5 system, that's going to be really annoying to solve by hand. And if you get bigger and bigger and bigger, it becomes, basically unfeasible to solve by hand. So what we can do is use Matlab to solve it. So if you're taking 250B for linear algebra now or in the future, you can use Matlab to check your work too. Okay, so consider this system of equations here. We have 4 equations here and 4 unknowns. If you're going to solve this by hand, again, it'd be pretty tedious to do. So what we can do is instead use Matlab, and we can solve for this in just like, in less than a minute. It's going to be great. So I'm going to go through 2 different methods for solving this in Matlab. So the first method is going to be using the inverse function in Matlab. So what we can do for our system of equations here, so we have, again, 4 equations with 4 unknowns, the unknowns being x1, x2, x3, and x4. We can rewrite this into matrix form like this. So we have, if we go back here, you see we have 5x1, 2x2, 3x3, 4x4. I've now rewritten it in matrix form. So again, if we were going to multiply this out, we have 5x1, 2x2, 3x3, and 4x4. So we have our system of equations. It's just rewritten in matrix form. And on the right hand side, we have our, what's typically going to be called our forcing vector. And again, that's just what we had in the slide before. Okay, so we can put it in this matrix form, and we can solve for x. That's our solution vector right here. And we can do that by taking the inverse of our matrix A and multiplying it by our forcing vector B. Okay, so that's the general way that we can solve for this system of equations. Now, of course, this isn't a Matlab or a math class, so I'm not going to go over the nitty-gritty details of it, but this is what we have to do to solve for our solution vector x. Okay, and then a little, I guess, a math note. The inverse of A, so to get the inverse of this matrix A here, we can only do that if our matrix is square and if it's non-singular, so basically if if it's not symmetric. If it's symmetric, we're going to run into problems. As I found out, well, not found out, but I was taking a test for my other class, and I had a symmetric matrix when it shouldn't have been symmetric. So that kind of sucked. Okay, so that's what we're going to do. So again, there's two different methods to do this in Matlab. So the first method that we have here is using the inverse function. Okay, so I'll do inverse function. Okay, so basically what we're going to do here is solve for the linear system that we just saw. Okay, so we're going to solve for this inside of Matlab. Okay, so I'm going to define my matrix A. That's 5, 2, 3, 4, 1, -4, 10, 2, then 3, 1, 3, 4, 0, 9, -1, 3, and then our forcing vector, remember that's B, that's this vector on the right hand side. That's going to be 2, 3, 4, 5. Okay, now I can solve for this by using the inverse function with Matlab. So what we're doing here is just using this equation right here to solve for the solution vector. So x equals the inverse of our matrix A multiplied by the forcing vector B. Okay, so I'll do x inverse just as our variable here. And we're going to use the inverse function, so that's just I and V. So we're going to get the inverse of our matrix A and multiply it by our forcing vector B. Okay, if I run this, then we get our solution. So that's all it took. Just a few lines of code. We just had to build our matrices or our arrays. And then we just solved for it using the inverse function. So really simple. So have fun doing this by hand, or you can do it this way and save a lot of time. Okay, and before we finish, the other method is using left-hand division. So let me change my section title. Okay, so we talked about left-hand division before, kind of early in the semester. Oops, left-hand division. So this is just another method to solve for our linear system of equations. And basically, this is just a more efficient method. So instead of using the inverse function, we're going to use left-hand division. So I'll call this variable x underscore LD for left-hand division. And for this, all we have to do is use our matrix A, and then use left-hand division divided by our forcing vector B. And now if I run this, I'm going to unsuppress both of these. I'm going to get the same solution here. So you see they're the exact same. So both methods, they do the same thing, but left-hand division is more efficient. So if you had a really big system of equations, you should use left-hand division. So really in practice, it's going to be better to use left-hand division, just kind of as it's the standard method to use in Matlab. So you can use this inverse method. It looks a little more intuitive for this equation here, but again, left-hand division is more efficient, so you should use that when you can. Okay, so I know we went kind of fast at the end there, but this is again an important thing to know for really for your classes or just in general, so it can save you a lot of time. But we're out of time now, so I'll see you guys on Wednesday. Again, we're gonna have a quiz on Wednesday, so it'll be on what we just covered in the lecture. It might be one question, it might be two. So study interpolation and this left-hand division, or the left-hand division method and the inverse method, and we're gonna have a quiz. Okay, so it'll be very easy. I'm gonna make it very simple, but just make sure that you go over the notes. Okay, so I'll see you guys on Wednesday.